All right, welcome aboard. Today we're going to be talking about how to invert a 3x3 matrix. We're going to break it down BRNY style right now. We're going to start with our standard form. Our matrix A0 is going to be equal to ABC, DEF, GHI. So let's create a matrix. Matrix A is going to be equal to 1, 2, 4, 0, 1, 4, 5, 6, 0. Step 1, we're going to solve for the determinant of our matrix A. The general formula for our determinant of matrix A0 is AEI plus BFG plus CDH minus GEC minus HFA minus IDB. Subbing in these values using our matrix A, we're going to solve for the determinant of matrix A. AEI is 1 times 1 times 0, plus BFG is 2 times 4 times 5, plus CDH is 4 times 0 times 6, minus GEC is 5 times 1 times 4, minus HFA is 6 times 4 times 1, minus IDB is 0 times 0 times 2. Let's simplify here. 1 times 1 times 0 is 0, plus 2 times 4 times 5 is 40, plus 4 times 0 times 6 is 0, minus 5 times 1 times 4 is minus 20, minus 6 times 4 times 1 is minus 24, minus 0 times 0 times 2 is 0. 40 minus 20 minus 24 is negative 4. So the determinant of matrix A is negative 4. And remember, when you're doing this, you always do the determinant check first, where your determinant of matrix A cannot be equal to 0, because the determinant is going to end up in the denominator in a couple of steps, and we cannot have a denominator equal to 0. Step 2 is to solve for the minors. Easiest way to set this up is like a tic-tac-toe board. Essentially what we're going to be doing is solving determinants of minor matrices within matrix A. So top left corner, EFHI, top middle, DFGI, top right, DEGH, middle left, BCHI, middle, ACGI, middle right, ABGH, lower left, BCEF, lower middle, ACDF, lower right, ABDE. So essentially what we're going to be doing for each one of these cells is computing the determinant, where we'll be multiplying this direction minus that direction. So when we plug in these values, we have a minor setup right here. So let's go through it and get our minor determinants. 1 times 0 is 0, minus 4 times 6 is negative 24. 0 times 0 minus 4 times 5 is negative 20. 0 times 6 minus 1 times 5 is negative 5. 2 times 0 is 0, minus 4 times 6 is negative 24. 1 times 0 is 0, minus 4 times 5 is negative 20. 1 times 6 is 6, minus 2 times 5 is 10, equals negative 4. 2 times 4 is 8, minus 4 times 1 is 4. 1 times 4 is 4, minus 4 times 0 leaves us with 4, and 1 times 1 is 1, minus 2 times 0 is 0, leaves us with 1. So our minor matrix is right here. Step 3, we're going to adjudicate. ADJ of A, or the adjudicate of A, is going to be the minor matrix times the scalar setup. Plus minus plus, minus plus minus, plus minus plus. Negative 24 times a positive is negative 24. Negative 20 times a negative is 20. Negative 5 times a positive is negative 5. Negative 24 times a negative is 24. Negative 20 times a positive is negative 20. Negative 4 times a negative is 4. 4 times a positive is 4. 4 times a negative is negative 4. 1 times a positive is 1. So this is our adjudicate matrix of matrix A. Step 4, we're going to transpose our adjudicate matrix, which means the first row is going to become the first column, and the second row is going to become the second column, and the third row is going to become the third column. So the adjudicate transpose is 24, 20, negative 5, as I was. Negative 24, 20, negative 5. Negative 24, 25, because the first row became the first column. Moving on, 24, negative 24. 24, negative 24. And finally, 4, negative 4, 1. 4, negative 4, 1. And finally, we're going to solve. We're going to do 1 over the determinant, which was negative 4. So that's 1 over negative 4 times our transposed adjudicate matrix over here. So this one is identical to this one. And now when we go through it, we're going to get negative 24 divided by negative 4, which is equal to 6. 24 divided by negative 4 is equal to negative 6. 4 divided by negative 4 is negative 1. 20 divided by negative 4 is negative 5. Negative 20 divided by negative 4 is 5. Negative 4 divided by negative 4 is 1. Negative 5 divided by negative 4 is positive 5/4. 4 divided by negative 4 is negative 1. And 1 divided by negative 4 is negative 1/4. So the inversion of our original matrix A is right here. And that's how to invert a 3 by 3 matrix BRNY style.